Okay, welcome to section 9.1, mathematical patterns. This is a new unit, and in this unit we're actually going to be talking about arithmetic and geometric sequences and series. But before we get into talking about those specific types of sequences and series, we're actually going to talk about what a sequence actually is. And so the first section is actually called mathematical patterns. Alright, and so here's what's important that we're going to try to get out of this lesson. Number one, a sequence is just an ordered list of numbers. Okay. Number two, each number of a sequence is called a term. Okay, and these terms can be represented by variables. Most of the time when we talk about sequences or series, we use a as the variable. So for example, when we talk about a sub 1, that's actually the first term. A sub 2 is the second term, and a sub n is the nth term. We can also look at different numbers, such as a sub n minus 1, that's the previous term, and a sub n plus 1, that's the next term. So what we're going to do is we're going to look at 4 different examples, and we're going to try to find some missing terms, write equations or write rules for each of these. Okay, and what we're really going to explore in this next little part is two different types of equations that we can write: explicit versus recursive. So, explicit versus recursive, what's the difference? Okay, an explicit formula describes the nth term of a sequence using the variable n. Okay, so meaning really the big difference here is explicit doesn't use the previous term to get the next term, whereas when we talk about recursive formulas use the previous term to get the next. Well, let's look at an example of an explicit formula. So we're describing the nth term, maybe it's the 5th term or the 6th term, and we're going to describe that sequence using n. So let's talk about this sequence here. It's just a sequence of numbers. We call this a finite sequence because there's no dots afterwards. It's just 4 numbers, then it stops. 2, 4, 6, and 8. Okay, first term is 2, second term is 4, third term is 6, fourth term is 8. So when we look at it, n, 1, 2, 3, 4, those are n values, so we can say 2 times 1, 2 times 2, 2 times 3, and 2 times 4 gives us each of these terms. And that's what they're talking about with explicit formula. You describe the term you want using n. So if we wanted the third term, it's 2 times 3 to give us 6. Okay, we're not using that previous term. So when we talk about recursive, a recursive formula relates each term after the first term to the one behind it, or the previous term. And the notation looks like this. A sub n equals a sub n minus 1 times minus a number here, and we have to make sure that n is greater than 1. This is just one example of a recursive formula. So it's not the same for all of them, but this is key. The a sub n minus 1. So recursive formulas use the previous term to get to the next term. So we're going to run through 4 examples here. In example number 1, we're going to find the first 6 terms of the sequence a sub n equals 2 to the n plus 2. Looking at this equation, I would tell you that it's explicit because we don't see the n minus 1. We're not using the previous term to get to the next term. This is an explicit formula. We're looking at the nth term and we define it using n. Okay, so the 6 terms: a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, a sub 6. Each time we're going to plug in the numbers 1 through 6 in for n and simplify. So a sub 1 means 2 to the first power plus 2, because that's where our n is. Our n is the exponent. So we get 4, 2 squared is 4, plus 2 is 6, 2 cubed plus 2 equals 10. If we're looking at the 4th term, a sub n, a sub 4, is equal to 2 to the 4th plus 2, and that's 18. 5th term, a sub 5, that's equal to 2 to the 5th plus 2, and that's 34. So these are the first 6 terms of the sequence for this particular equation. Now, in problem number 2, we're going to write a recursive definition or a recursive formula for this sequence. 1, 1/2, 1/4, 1/8, and 1/16. And notice the comma, dot, dot, dot. We would consider this an infinite sequence because of the comma, dot, dot, dot. That means the pattern is going to continue on that trend forever. So that would be called an infinite sequence. All right, so when you write a recursive formula, there's two things you need. You have to identify the first term, and then you have to write an equation. And when you write the equation, you have to relate the previous term to get to the next term. So the first part's easy. First, identify a sub 1, the first term. Well, the first term here is just 1. So I write that. Done with the first part. Second part, we have to determine how we can get the next term using the previous term. So I picked out 1/4. And I look at 1/4, and the previous term to that is 1/2. So how can I use 1/2 to give us 1/4? Okay, well, 1/2 times 1/2 is 1/4. If I looked at 1/8, okay, how could I use 1/4 to get 1/8? Well, 1/4 times 1/2 is 1/8. So I've got something here. I've got the pattern. I know that if I take the previous term, any previous term, and multiply it by 1/2, I get the term I want. For example, if I want the sixth term, all I have to do is take 1/2 times 1/16, and I get 1/32. That is the sixth term. So, to write the formal definition, we include two things. The first term, a sub 1 equals 1, and here's the formula. To find the next term, I take the previous term and multiply it by 1/2. That's my rule. That's my definition. That's my formula. Problem number 3. Write an explicit formula for the sequence 7, 14, 21, 28, and 35. So this time we're going with the explicit formula. Now this means we don't have to use the previous term to generate the next term. So I've rewritten the pattern here, or the sequence. This would be finite because there's no comma, dot, dot, dot. Finite. We were only looking at these first 5 terms. Okay? Well, I notice all of these numbers are multiples of 7. 7 times 1, 7 times 2, 7 times 3, 7 times 4, and 7 times 5. Now, the second term is 14. 7 times 2. Okay, notice if I wanted the second term, a sub 2, it would be 7 times 2. The third term, 7 times 3. So I've kind of figured out my rule here for explicit formula. Whatever term I want, a sub n, I just have to take 7 and times that term I want. The second part of this I wrote in blue. They want to know the 20th term. Now a recursive formula would be very difficult. We would have to know the 19th term in order to get the 20th. That would be very tedious to write all out. So sometimes it's better to use that explicit formula, and that's why we wrote it here. So how do we get the 20th term? Well, a sub 20 is just equal to 7 times 20. And I get 140. So the 20th term of this sequence would be 140. Okay, so be very careful when we talk about that. We know the term we want is just 7 times whatever term we want. You know, the second term, a sub 2 equals 7 times 2. And so this right here, that is our rule, that is our definition. That's what our answer would be for that formula. Okay, and then this is a sub 20. A sub 20 would be 140. All right, guys, our final example, problem number 4. Find the 8th term of the sequence, 400, 200, 150, 25. Hopefully you look at that and say, that's finite, because there's no comma, dot, dot, dot. Well, it doesn't ask me whether I need an explicit or a recursive formula. In this case, I actually chose to do a recursive formula because I have the first 5 terms. I only need to go out to 8, so it's not that much extra work. I know my first term is 400. So what I have to do now in order to find the 8th term, I have to write a recursive formula, an equation. Well, if you look at this, 200 is just half of 400. 100 is just half of 200. 50 is half of 100. So I think I've got my equation. Whatever term I want, I just have to take the previous term and multiply it by 1/2. I have 5 terms here. I need 6 and 7 in order to get 8. Okay? In order to find the 8th term using a recursive formula, I have to know 7. So to find a sub 6, I just take that last term, 25. There's the previous term. A sub 5 is 25, so the previous term times 1/2 is 12.5. So that's a sub 6. The 6th term of the sequence is 12.5. So I could write that. To get a sub 7, I take the previous term and multiply by 1/2. So 12.5 times 1/2, that gives me 6.25. And finally, let me clean this up just a little bit here. A sub 8 is just taking a sub 7, the previous term, and multiplying it by 1/2. So 6.2 times 1/2 is 3.125. Okay, so those are mathematical patterns, and we talked about explicit and recursive definitions or formulas. In the next coming sections, we're going to actually look at particular sequences and series when you have a common difference or a common ratio, and that has to relate to arithmetic and geometric sequences and series. Again, if you guys have any questions, post the questions below. If I make any mistakes, post them below, and I'll take care of them for you. See you guys.